Okay, so this next question here is an interesting one. It's someone that is driving in a car drops a pebble while they are moving, and we want to know how far from the spot that they dropped it. We want to know the horizontal distance that it travels in that time. So if someone in a car is going past you at a speed of 49 meters per second, now that is like super fast. That's like over 150 kilometers an hour. So that person is clearly speeding, but besides the point. They drop a small rock from a height of 2.5 meters, and that is a really tall car. Okay, so this question is kind of funny. So that would be like a bus going at 150 kilometers an hour. Anyways, question says, how far from the point of the drop will the rock hit the ground? Okay, hit the ground, and acceleration due to gravity is 9.8 meters per second squared. And my answer is in meters here. So this one's going to be a little bit of a tricky setup, but once we get it, it won't be too bad. So I'll start off by writing down my vertical information. So this is going to be my vertical, meaning dealing with gravity information. So I have to break it down into vertical info and horizontal info. So here, my initial velocity vertically, if I'm holding it in my hand, is 0 meters per second. Now, it's moving 49 meters per second, but that is horizontally. So vertically, the initial velocity is 0. The distance that it's going to travel vertically is 2.5 meters. The acceleration due to gravity is 9.8 meters per second squared. And I want to know what the time is. Okay, I don't know the final velocity, but I don't need to know that. So now I need to look at my kinematic equations and figure out which one deals with initial velocity, distance, acceleration, and time. And this one works out nicely because I know this one, my distance traveled is my initial velocity times my time plus half my acceleration, and I'll put g because it's due to gravity, times my time squared. Okay, now my initial velocity is 0, so this first term here gets cancelled out. So that would mean my distance will be half acceleration due to gravity times delta t squared. Now some of my students struggle with the algebra part. So here I'm going to multiply this by 2 to cancel that out, and I'll multiply this side by 2 as well. And here I'll bring that back up over here. So then I get 2 times my change in distance is gravity times my time squared. I'll divide by g on both sides, divide by g here. 2 delta d over g is equal to my time squared. And now to get time by itself, I'll have to square root both sides. Okay. So here, I'll put in all my numbers. 2 times 2.5 meters divided by 9.8 meters per second squared. And my units all work. I have meters here, meters per second there. And when I work that out, I get my change in time here. Now you have to watch how you put this in your calculator. Maybe do it, a piece at a time. But I work it out. My change in time is 0.714 seconds. So that's the time it took to drop from the 2.5 meters all the way to the ground. So this is my vertical portion. Now I'm going to take this time and use it in my horizontal portion as well. So here, my horizontal information, I have no acceleration horizontally because the acceleration is due to gravity, but it is not accelerating horizontally. So that means that I can use my distance is going to be my velocity times my time. Okay, this is a non-acceleration question. So here my distance, my velocity is 49 meters per second times my time, which is less than a second. So I know it will travel less than 49 meters. And I work that out, and I get 35 meters. So if I was to draw this, I'd have a vehicle traveling really fast, okay, traveling this direction, and the stone would be dropped here, and it would travel a fair distance. This here would be 2.5 meters, but this horizontal distance would be 35 meters. And this here is the answer that I want to put in. So 35 meters, if I pull up my answer screen here, number 7, I'll plunk that in, 35, and submit that. Nice. So good luck on that question. Remember, always split it into 2 sections, your vertical motion and your horizontal when dealing with projectiles.